So, what did we talk about yesterday? Just a quick overview, and I will give you another go at it. I'll add some notes here to help you understand it a little better. But we talked about the first word we talked about was accuracy. Anybody using your own words? What does accuracy mean in this unit? What would we define it as? Accuracy. Mark, say that a little louder. I didn't hear. The exact amount. Okay, we're getting closer. I think we're getting somewhere, but there's something we know. Like accuracy is how. Listen carefully. Yeah, Quentin. How exact. So it has to do with exactness. Yes. So to put it in plain words is how close you are to the actual target measurement. That's accuracy. How close you are to that measurement. Because if I look at this pencil here, I'm going to put it on the video. There is an actual measurement for this thing. So if I were to use a ruler or something, right? Accuracy is how close this measurement that I'm taking is to the actual measurement of this thing. So that is accuracy. Okay, how close we are to the actual target. And so that's accuracy. What is precision? Who could say, oh, let's go back to accuracy. What are two things that need to be considered when determining whether or not a measurement is accurate? Two things. You can cheat. You can go back in your notes. Right? There are two things you need to consider when we're talking about accuracy. We kind of always, we would write like scale and the unit we're using. Remember? Can you use your foot or a forearm or a handspan? Would that be a good unit? It would not, because you cannot repeat it. Accuracy, you should be able to repeat that measurement. So we're talking about scale, and we're talking about the unit that we're using. Okay, what is scale again? Well, you wouldn't use a teaspoon to transfer, like a farmer, right? If you wanted to measure like how much grain you brought in, you wouldn't use a teaspoon, right, to measure that. You wouldn't use centimeters to measure the distance between Sisler and your home, right? You wouldn't do that. You would use meters, or if it's far, kilometers, so forth, okay? What is precision? Precision is a little bit harder to define. So maybe I'll ask you to just go to if you go to page 82 real quick, let's just look at that side note on page 82. The smallest unit of measurement on the device. Okay, it's the smallest increment on the device. And uncertainty follows. We get it from the precision. Okay, uncertainty is half of the precision. Okay, and uncertainty is known as the margin of error, because you could be off by a certain amount, right? So let's go back to page 80. Let's do a quick question here. Between these two measuring devices, did I tell you what this is called yesterday? Caliper, yes. And so this is used so if you're manufacturing something that's small and you want to know exactly how wide that is, right? You would pinch it, and this would give you a measurement here exactly. You could also, would a ruler be a good device to measure the thickness? Would it be as precise as this? No, this would be more precise, right? This has, unfortunately, I'm out of battery here, right? But you would have like 3 decimals here. There's what?
What did the girl say? Only thing I heard is police. That's the only word I heard. Police? Your mom.
What you like this? Huh? No, we're going straight there. And then no, police. I need a direction. Oh yeah, okay. I'll go with you. Or what happened?
Okay, so on page 80, we'll just review before I'm going to give you a short AC after this. Okay, so first we're going to just write this down so we know how to state precision. Write this down on page 80 because you need a few more examples. So state precision and uncertainty. And this is how we're going to break this down. A number is given, number or value. Okay, that's going to be a column right there. Then we're going to have a picture or an image. And we're going to have words. Okay. So 3 instances where I'm going to ask you, hey, I'm either going to give you a number, state the precision and the uncertainty, a picture, or it's going to be in words. So let's say you're given a measurement like this, 17,851.25 kilometers. Right? And I'm going to ask you, state the precision and the uncertainty of this measurement. Okay. A device has been used to measure this, right? To come up with this, you use some kind of device, okay? So the precision here of this measuring device, we're just assuming, is to the nearest what? 0.01. Like you focus on that second decimal. And so you're saying that this measuring device can go up or down by 0.01 every single time. And we stick with the kilometers. Okay? How do you get uncertainty again? Do you remember how to do that? You divide it by 2. That, once you get your precision, even if you get precision wrong, if you divide it by 2, you still get the marks for uncertainty. And so if you do that, you get 0.005 kilometers. So there's your uncertainty, and there's your precision. I will give you one more example involving fractions. So block this off here. Let's say I give you a measurement that's 7.5 inches. if you go, what would be the precision when something like this is given to you? What are we going to assume? Half an inch. Yeah, we're assuming, we don't know, but we are just going to assume that this measuring device can only go up half an inch at a time. Okay? And so the uncertain, and most of us would say, hey, can I just write it as a decimal? Absolutely. Right? And I probably would encourage you to do that. And so the uncertainty is 0.5 of an inch divided by 2, which is, this is good mental math, 25, right? 0.25. So there's your precision, and that's precision and uncertainty, and they can be written as a fraction. You can write it as a decimal. It doesn't really matter. Make sure they have units every time. So there, that's how you do it when you're given a number. You just go by the number. Okay? Next, with a picture, right? So I'm going to do this again, but a little different. I'm going to get you oh, all right. So let's do this. I know I gave you something similar yesterday, but I'm going to do this again. So let's say you get one of those, and we're going to go 1, 2, 3, 4. We're going to have 4 bigger lines like this. Try to make them equally spaced apart. And then in between them, we're going to have smaller marks. That's how a lot of gauges are. Okay. And I'm going to say this. We're going to assume that this is in degrees Celsius. This gauge is telling us the temperature in degrees Celsius. And we're going to go 80, 100, 120, and 140. Okay. Let's put that phone away. Matthew, put that phone away. Okay. Ryan, put it away. Okay. Yeah. Recognize that gas.
Well, that guy was an old black hair.
What? He's in the pump with you. Page 80.
All right. So this gauge right here is going up by, what is this going up by? Like if you had, it looks like it's 20, right? But it's actually going up by 10. The smallest increment, if you look at it, right, this would be 10 and another 10 to get you to 100. Okay, so what you need to write down here, the precision is 10 degrees Celsius, and the uncertainty would be half of that, which is 5 degrees Celsius. How would you be able to tell, like, because sometimes there's going to be more markings in between. How would you do that? This is how you do it mathematically. You take the closest two numbers that you see, you go 100 minus the lower one, and you split that in how many gaps there are, right? So in this case, it would be 20 divided by 2, which is 10 degrees Celsius. That's basically how I got my precision there. Okay, and the uncertainty is 5 degrees Celsius. So we have that. So we have a number, picture given. It could be a beaker, it could be a syringe, it could be whatever, right? Temperature, it could be hertz, like for sound. It doesn't matter, you just write it down. Words. A measuring cup has markings of 150 milliliters. And what I want you to do, whenever you see markings, it trumps everything else. Okay, markings of 150 milliliters. Okay. That is, if you see markings or to the nearest, how about this? I'm going to add that because sometimes to the, write this down because it's important, to the nearest 150 milliliters. That's what this is saying, like that you can only measure to the nearest 150. Okay, so my precision is definitely going to be the markings that they're telling me already, right? They're telling me it's 150. Uncertainty, what's half of 75? This is a good mental math. Half of 150? 75 milliliters. Okay, so there's your precision and your uncertainty there. And I'm going to add this. I actually don't need this line here, so I'm going to erase some of it. I'm going to close it there, and I'm going to add a little note here. Okay, very important. The measuring device with the smallest increment is more precise. Okay, smallest increment will be more precise. Which one of those two would be more precise if you had to make a decision between one of them? 435.2 you would say? Everybody else? What are we thinking? Raven, what are you thinking? You're not thinking? What are we? Well, which one is like, just think about precision. Precision, you're worried about the smallest, right? You want to be really close. Which one would allow you to get closer? Don't look at the bigger number. So you're saying this one? I think that's where you're pointing. Yes, this one is more precise, right? This one is, the precision here is 0.12, right? Two numbers and then a third value there. 1 second. So this one wins. It's more precise. What if you would have to just say what if I gave you one of those? Which one of these two would be more precise? Millimeters? All right, look at the units. Like if the units are different, the smaller units is going to win. The smaller unit will win. Okay? Smaller unit, right? And this one is just more precise. Okay? So you should be writing this down. I hope you are. And this was on page 80. Okay. So yeah, I'm willing to photocopy this, ladies. If you want me to just, you can photocopy this or whatever later on. No problem. I know that it wasn't. You had to do the right thing there. I will give you an AC right now. Based on this, you should recognize it if you did the work yesterday. So just close your books, just have the front facing up, okay? Everything else is gone. Study sheet, if you have something on there, you can have it. All right. So write in this as I'm going over it, right? You can make corrections. So it's asking us if it would give an accurate measure, if the measuring device is appropriate, if the scale is appropriate, that is. So in this case, you're using a foot. So unit is not good, not appropriate. Or you can say not standard. You can talk about the unit, and the scale is appropriate. Like using your foot to measure the gym floor, that would actually be good. So unit fails, scale is okay, but we still make a final statement it's not accurate. You would not be able to remember accuracy. You need to be able to repeat that measurement, and if you ask somebody else to do it, you couldn't repeat it. Say that again. I would need to, moving forward, talk about the unit that you use, foot, handspan, whatever, and then whether or not the scale is appropriate. If they both have a check mark, then it is accurate. So for today, yes, we'll do that. Use a teaspoon to measure the correct amount of baking powder on a chocolate cake. So first of all, the unit is standard. So that's a check, right? And the scale, what do you think? It's a great scale. Scale is appropriate, right? So we do check mark, therefore accurate. You asked anybody to put 2 teaspoons of baking powder in there anywhere, 2 teaspoons, right? Could you be using it the wrong way? Like what are anybody in baking? Question? I'm gonna let you keep it. Today I'm gonna let you keep it, so I'm just getting you. I kind of tricked you a little bit because I think you need a bit more. So no marks. It's just for tomorrow. Yeah. Teaspoon. You have to swipe it off, exactly. If you leave that little, if you're making coffee, right, and you make a scoop and you let it like go build up like that, that's not a teaspoon. Now you're putting in probably 2 or 3, right? So you need to use it properly. Okay, point made. All right. Circle the measurement that's more precise. Uh-oh, I don't have in there. There we go. Back up. Okay, more precise. So between these two, which one would it be? This one. It's down to 0.01. This one is only 0.1. Between these two, they're both in centimeters, and it's the one that has the most decimals. Between these two, millimeters obviously wins. So don't look at the actual value, look at how precise is it? What is the smallest increment it can possibly have? Between these two, notice that this one is going up by 50 every time. This one is going up by 100 every time. So this one is more precise. Even though it's smaller, it's more precise. That's quite often the case, right? Like something that is smaller will need to be precisely calculated, right, to make sure it fits. Next page. State the precision and uncertainty in each case. This would be 0.01 of a centimeter. If you take that and divide it by 2, you get 0.005 of a centimeter. Right? You split the precision in half. Precision here is 0.1 kilogram. Always have units. You split that in half, you get 0.05 kilograms. That's your uncertainty. Based on the image here, my precision, I'm going up by 50 every time. That's very easy to pick out. So 50 ml is your precision. Your uncertainty is 25 milliliters. So there's how you read these things. Be careful, read carefully that image. Make sure you figure it out. If there had been one of these, if this thing had markings yet that are in between, then we would say that, right, technically this is 275, so then it goes up by 25 at a time, so you got to watch out for that. Be really careful when you have this. So you can put this in your notes or whatever. Back to your books, 85. So I'm hoping that after today, if you still had any doubts about precision and uncertainty and all that, you'll have a pretty good grasp on this. Okay? So go to 85. If you have a highlighter, great. And remember, you need to start working on a study sheet for this unit. You need to have something in there for this unit. There's 0 on that on your formula sheet. Precision measurement has nothing on here. So you're completely down to the study sheet, right? And I will give you a little bit of help today as well at the end. I'll give you some pointers, like this is what I would put on there, and you can add to it. I would not be putting it on there as much as you, because I have done this so many times, right? You probably need to add a bit more. So we have on page 85, we are, example 5. We're mixing juice in a jug that is marked in quarter liters. So highlight that, very important. She measures the amount of juice in the jug to be 2.5 liters. So what's going on here? Because it says marked in quarter liters, and you're like, wait a minute, Mr. Dirksen, there's marked and there's the number, the actual value. Which one would you go by to get your precision? The marked. Yeah, okay. So what's my precision here? Quarter liters? It's exactly what it says, quarter of a liter. And what's the uncertainty? What's half of that? Mental math. If you need to use a calculator, you do that, right? You split that in half and you get 0.125. So how about this for your notes? Because you might be coming back to it after the break. Just put it divided by 2. That's how we got it. So the uncertainty will never be just obvious, visible. You have to extract it from the precision. Okay. Write the measurement of the juice in the jug in this form. Box this in, please. I will ask you quite often to state the measurement, not just like 2.5, but I will ask you to state it with its uncertainty. Okay. So what's the measured value? Well, that's the one they're talking about. There's 2.5 liters in this jug, but it could be over or under by 0.125 of a liter. It's kind of silly to talk about it that way. Nobody ever does that in real life. If you say that's 2.5 liters, then that's what it is. But in this unit, mathematically speaking, you could be over or under by this much. You're kind of like gauging it. You're just ballparking, right? You're just making like an estimation there. So you could be off there. So this is what they're talking about when I ask you to state it like this. Is the precision anywhere in here? It's not a trick question. Is the precision in here? Is the 0.25 in here? No. Don't make that mistake. I see that quite often. It's the uncertainty that goes in here. So we're done there. And usually what will follow, this step may or may not be there. But I will, basically they want to know what's the smallest and largest possible volume that could be in that jug. So smallest, that's what we call our minimum, is going to be 2.5 liters minus the 0.125 liter. We're going to get a number there. And our largest volume, that's going to be a max 2.5 liters. And it's max, right? So you're thinking grade the largest amount that could be in there. So we're going to subtract and add. I would like you to use your calculators for these. So just make sure you're okay working with 3 decimals like that. Shouldn't be a problem. But do not round in this unit. Remember I told you that? You should have written that down at the very beginning of this unit. Do not round. So it's 2.375 liters is the minimum. And then you just add 2.5 plus 0.125. That's 2.625 liters. Okay. So really you could have as much as this or as little as that, even though you're saying it's 2.5 liters. Have you ever checked how much is actually in your can of soda? Did you ever check if it's 355 milliliters? No. Who does that? Nobody does that. But would you think that every single can has exactly 355? No. Some have more, some have less. And they know that. That's not a secret. In production, that's not a secret. So there's something that they allow. They allow some discrepancy, okay? What is the range of volume that could be in the jug? This is a formula you need to write down. Range is found by taking the maximum we just calculated and subtracting the minimum. I'm going to box this in. Okay. You need to have that. I'm going to highlight that. Right. So our range here is the max, which is 2.625 liters, minus 2.375 liters. And when you do that, you get 0.25 of a liter. That is the range. That's the range. Range is what's the difference between the smallest and largest. That's always the range. Okay. Okay. Before I let you work completely on your own, I'm just going to assign you one question that is just like this, which is the question 12 here. Try now. I want you to try it. Don't just stare at the board, right? And I'll just remind you that 1 meter has 100 centimeters because you're going to need that. So try grade 12. I was going to say try grade 12 right now. You are trying it. Try question 12 right now. And then I will assign some questions specifically for you to try for the rest of today's class, okay? Okay. Let's see if you got this. So it's saying that Frank measured his height as 1.75 using a tape measure marked in centimeters. Is that important? Absolutely. Okay. It says write the height as measured value plus or minus the uncertainty, measured uncertainty. So what they're saying is Write down 1.75 plus or minus the uncertainty. We don't know what the uncertainty is, but we can tell from this statement that our precision is 1 centimeter, which in turn tells me that my uncertainty is going to be 0.5 centimeters, correct? And this is the number I place over here. So it's plus or minus 0.5 centimeters. Do you notice that the units are different? That's why I told you that 1 meter has 100 centimeters. So basically what you do to this is you multiply. This is technically acceptable, but I like to have them all in one unit. So 175 centimeters plus or minus 0.5 of a centimeter. This is really what I would say would be the best answer. Notice that I went from meters to centimeters. Both units are in centimeters. That's why we did this here. Okay. Next, what is the range of possible values of his actual height? How do you get the range again? Let's go back up here for 1 second. It's by taking the maximum and subtracting the minimum. We haven't done that yet, have we? So let's write this down here. The minimum possible height for Frank will be 175 minus 0.5, and the max will be 175 plus that uncertainty we just found. They're both in centimeters. So this will be 174.5 centimeters, and this will be 175.5 centimeters. Now we can figure out the range, because the range is taking the max and subtracting the min from it. So we take 175.5 minus 174.5. So the range is 1 centimeter. That's how you do that. So to get the range, you need the min and max, which it didn't ask you to do. It didn't guide you through it, but it's supposed to be like that. Okay. I'm going to give you the questions to work on and the study sheet entry. Yeah, so I guess it goes without saying, this isn't going to just flow naturally. This isn't just, oh, Pythagorean theorem, I've seen it since grade 7, right? It's going to be, this is new material. So write this down. These are the questions I want you to do. Page 86, the one we're on right now, plus if you go to page 90, only do questions 4 and 5. Write this down at the top of this page. Those are the questions I want you to do. Oh, you see where it is? Is it right? Yeah. Okay, did you write this down? At the bottom of this page, there's lots of room there, and the reason I left it is to add what I'm about to So at the bottom of this, there's lots of room. Leave a little bit of room to answer B here. But then I will zoom into that in a bit. Give me 1 second here. So this is what I did for myself. I said that accuracy is how close to the target you are. You need to consider the units and the scale. You should be able to repeat it. Precision is the limit of the device, like how limited it is. You can get it from a number, from a picture, or from the words, where it says markings, right? Uncertainty is the margin of error, or how much you could be off by. And it's found by taking your precision and dividing it by 2. So I would say U is equal to precision divided by 2. So all the boxed in ones here are formulas that you should probably have on your study sheet. Okay, so this is at the bottom of that page 86 that I've just given you. Try to make that find its way to a study sheet.